Imagine being able to speak a language that can literally make things move, solve complex problems, and even build entire virtual worlds. Sounds like something out of a sci-fi movie, right? But here's the reality check. That language exists, and it's called coding. Whether you're an aspiring engineer or just curious about how technology really works, learning to code is like unlocking a superpower, a skill that can transform your ideas into reality. So, if you're ready to dive into the world of programming and discover how it's reshaping engineering, stick around. This is where the magic happens. Let's kick things off by addressing the big question: why should engineers learn to code? The answer is simple: because in today's world, coding is the key to innovation. Whether you're designing a bridge, optimizing the manufacturing process, or creating the next groundbreaking app, coding gives you the power to automate tasks, analyze data, and solve problems faster and more efficiently. It's like having an extra tool in your engineering toolbox, one that can turn a good idea into a game changer. But let's get straight to the point. What is coding, really? At its core, coding is about giving instructions to a computer in a language it understands. Think of it like writing a recipe, where each line of code tells the computer what to do, step by step. The beauty of coding is that it's incredibly logical. If you can break down a problem into steps, you can code. And once you get the hang of it, the possibilities are endless. Now, let's talk about programming languages. Just like there are different spoken languages, English, Spanish, Mandarin, there are different programming languages, each with its own strengths and quirks. Some of the most popular languages for engineers include Python, C++, and MATLAB. Python is like the Swiss Army knife of programming, versatile, easy to learn, and powerful enough to handle everything from data analysis to machine learning. C++ is the go-to for high-performance applications like robotics and simulations. And MATLAB? It's an engineer's best friend when it comes to mathematical modeling and algorithm development. Each language has its own flavor, and the one you choose depends on what you want to accomplish. But here's where things get really interesting. Coding isn't just about writing lines of text. It's about problem solving, thinking logically, and breaking down complex challenges into manageable pieces. Let's say you want to design a program that can calculate the stress on a bridge under different loads. First, you define the problem. What data do you need? What calculations will you perform? Then, you'd break it down into smaller steps, input the data, run the calculations, and output the results. Coding is the process of turning those steps into a language the computer can execute. It's like being a detective, piecing together clues to solve a mystery, but in this case, the mystery is a complex engineering problem, and the clues are lines of code. Now, let's dive into a few basic concepts that are essential for any engineer learning to code. Variables are like containers for storing data. Think of them as little boxes where you can keep numbers, words, or even entire datasets. Loops are your way of telling the computer to do something repeatedly, whether it's crunching numbers or processing data until a certain condition is met. And then there are functions, predefined blocks of code that perform specific tasks, like calculating the square root of a number or sorting a list. Functions are like the building blocks of your program, allowing you to reuse code and keep your programs clean and organized. But coding isn't just about writing code, it's also about debugging. Debugging is the process of finding and fixing errors in your code, and trust me, it's a skill every coder needs to master. Whether it's a simple typo or a complex logic error, debugging is where you learn the most. It's like being a detective on a mission, tracking down bugs and figuring out what went wrong. And here's a pro tip: don't be afraid to make mistakes. Coding is all about trial and error, and every mistake is a chance to learn and improve. So, why does this matter for engineers? Because coding is the bridge between theory and practice. It's what allows you to take the concepts you've learned in your engineering courses and apply them to real-world problems. Whether you're simulating the flow of air over a wing, designing a smart grid, or building a robot that can navigate a maze, coding is the tool that makes it all possible. It's not just a skill, it's a mindset, a way of thinking that's essential for solving the complex challenges of today's world. And here's the kicker: coding isn't just for software engineers or computer scientists. It's for anyone who wants to harness the power of technology to make a difference. As an engineer, Learning to code gives you the ability to automate repetitive tasks, analyze massive datasets, and even develop new technologies that can change the world. It's the ultimate tool for innovation, and once you start coding, you'll wonder how you ever got by without it. So, whether you're just starting out or looking to expand your skills, remember this: coding is the key to unlocking your potential as an engineer. It's not about memorizing syntax or learning every programming language under the sun. It's about learning to think like a coder, to approach problems with a logical, systematic mindset, and to see challenges as opportunities to create something new. Once you've got that down, there's no limit to what you can achieve.